What if the greatest change in human history isn't happening on Earth, but above it? We're living in an era where space exploration has leaped from government agencies into private hands. SpaceX, Blue Origin, Virgin Galactic, and countless others are just the beginning. The first steps toward a future where humanity reaches beyond our planet's boundaries. But where does this path lead us? As our technology grows more sophisticated by the day, we face questions that once belonged only in science fiction. Will these advances unlock unlimited resources and energy for the human race? Or are we about to discover threats we never imagined? Are we on the brink of finding our cosmic neighbors, or something far more profound about our place in the universe? So settle in as we explore space theories that could reshape humanity's destiny forever. Up first are Dyson spheres, megastructures that could harness the power of entire stars. Imagine being able to capture every single ray of sunlight, every burst of energy our star produces, not just the small amount that reaches Earth, but all of it. This isn't just another sci-fi fantasy. This is a concept that could revolutionize life as we know it, transforming humanity from a planetary species into true masters of the cosmos. Back in 1960, visionary physicist Freeman Dyson proposed something that seemed impossible: a megastructure that could completely surround a star. The idea was simple in concept, but staggering in scale. If an advanced civilization needed more power than their planet could provide, why not build something to capture all of their star's energy? Now let's break this down in a way that will blow your mind. Picture 3 possible designs for this stellar megastructure. First, imagine a complete shell, like a giant hollow ball encasing our sun. Every inch of its inner surface could be used for energy collection or even habitation. Second, think of a vast cloud of satellites, millions of them, dancing in perfect orbital harmony around the star, each one collecting energy like a cosmic solar panel. Third, picture a massive ring, similar to Saturn's rings, but built by intelligent hands, circling the star to harvest its incredible power. The implications? They're absolutely staggering. Right now, we worry about electricity bills, fuel costs, and energy shortages. But with a structure capturing the sun's full power, we'd have more energy than we could possibly use. Every home, every factory, every vehicle could run on clean, unlimited power. No more blackouts, no more energy poverty, no more choosing between heating your home and feeding your family. But here's where it gets really interesting. The surface area inside such a structure would be millions of times larger than Earth's. Imagine having so much space that overcrowding becomes meaningless. Cities could spread across distances that make our current metropolises look like tiny villages. Every family could have acres of land, with room left over for vast nature preserves, farming zones, and whatever else we could dream up. The possibilities don't stop there. With that kind of power at our disposal, we could finally achieve what generations have dreamed about: reaching the stars. The energy output would be so immense that we could power spacecraft capable of crossing the vast distances between solar systems. Humanity could spread beyond our cosmic backyard, becoming a true spacefaring civilization. Think about the computational power we could achieve. Our most advanced computers today would look like pocket calculators in comparison. We could process data at speeds that would make current supercomputers look like they're running in slow motion. Imagine solving complex medical problems in seconds, predicting weather patterns with perfect accuracy, or unlocking the deepest mysteries of the universe through sheer computational might. The construction of such a megastructure would mark humanity's transition from a planetary species to a stellar one. It would be like upgrading from a studio apartment to a mansion the size of North America. The energy we'd harness would make our current global power consumption look like a birthday candle compared to the sun. But let's get real for a moment. The challenges we'd face in building this would be enormous. We'd need to mine entire planets just to gather enough materials. We'd need to develop new construction techniques that could work in the intense environment near a star. The engineering requirements would push the boundaries of what we think is possible. And then there's the environmental impact to consider. Building this would fundamentally change our solar system. We'd need to become masters of artificial environmental control on a scale that makes current climate challenges look trivial. We'd be reshaping nature itself at a cosmic scale. Yet despite these obstacles, the concept continues to inspire scientists, engineers, and dreamers alike. Why? Because it represents something fundamental about human nature, our desire to push boundaries, to solve impossible problems, to build things greater than ourselves. Imagine looking up at the night sky and knowing that somewhere out there, another civilization might have already achieved this feat. In fact, astronomers today are searching for signs of these megastructures around distant stars. If we spotted one, it would be undeniable proof that we're not alone in the universe. The technology to build such a structure might be centuries away, but the very concept changes how we think about our future. It suggests that our energy problems, our space limitations, our computational boundaries, they're all just temporary challenges. We could overcome them all with one monumental project. This isn't just another scientific theory. It's a window into what humanity could become. When we look at our current challenges, energy shortages, climate change, overpopulation, we often feel trapped by the limitations of our planet. But this concept shows us that these limitations are temporary. We could transcend them all. Think about what this means for future generations. Our children might grow up in a world where energy is as abundant as air, where space travel is as common as catching a bus, where the computational power to solve any problem is at their fingertips. This isn't just about building a massive structure in space. It's about unlocking humanity's full potential. As we reach for the stars, this concept remains one of our most ambitious dreams. It pushes us to think bigger, to reach further, to imagine solutions that seem impossible by today's standards. In our quest to reshape the cosmos, this megastructure stands as the ultimate goal, a testament to what we might achieve when we dare to dream on a truly cosmic scale. Now let's talk about something that, if harnessed correctly, could actually change our lives forever. Imagine walking through a doorway in New York and stepping out onto an alien beach orbiting a distant star, all in the time it takes to cross a room. These, of course, are what scientists call wormholes. These cosmic tunnels through space wouldn't just revolutionize travel. They'd completely transform how we live, work, and explore the universe. Think about your daily commute. With a network of stable wormholes, you could live on a pristine planet 50 light-years from Earth while working at an office in Tokyo. Your kids could attend the best schools anywhere in the galaxy. Weekend trips to alien worlds would become as common as visiting another state. This isn't just about convenience. Access to wormhole travel would solve some of humanity's most pressing problems. Facing resource shortages? Step through a portal to mine precious materials from uninhabited planets rich in rare elements. Worried about overpopulation? We could expand to countless worlds, giving everyone the space they need to thrive without destroying natural habitats. The impact on human civilization would be immediate and profound. Imagine construction crews building colonies on distant planets, returning home each night to their families on Earth. Picture emergency response teams instantly deploying anywhere in the galaxy where they're needed. Consider farmers cultivating land across multiple worlds, accessing diverse environments to grow food year-round. But it's not just about moving through space. Some theories suggest wormholes could connect different points in time. Want to solve climate change? We could study Earth's atmosphere throughout history, gathering data from multiple time periods simultaneously. Need to prevent a disaster? We could send warnings to the past or gather solutions from the future. Communication would evolve beyond anything we can currently imagine. No more delayed signals to Mars rovers, no more waiting years for data from deep space probes. Scientists could conduct experiments across vast distances in real time. Teams could collaborate instantly despite being separated by millions of light years. The entertainment industry would explode with possibilities. Imagine virtual reality feeds streaming live from alien worlds. Sports leagues could span multiple solar systems. Tourism would encompass not just different places, but different eras. Historical research would transform from studying artifacts to witnessing events firsthand. Education would never be the same. Students could attend morning classes on Earth, take afternoon field trips to ancient civilizations, and study alien biology on distant worlds firsthand. Every classroom could have access to the entire universe as its laboratory. The medical implications are equally staggering. Hospitals could instantly share resources across the galaxy. Rare diseases could be studied simultaneously by experts from countless worlds. Emergency organ transport would no longer be limited by time or distance. Healthcare would become truly universal in every sense of the word. For business and commerce, wormhole networks would create a truly galactic economy. Manufacturing could happen anywhere resources and conditions were optimal. Supply chains could span the cosmos while remaining instantaneous. Markets would operate across space and potentially time, creating economic opportunities we can barely comprehend. Research and development would accelerate beyond our wildest dreams. Scientists could gather data from multiple points in the universe simultaneously. We could study stars throughout their life cycles by connecting to different time periods. The mysteries of quantum physics could be explored by linking laboratories across space and time. Even our approach to environmental preservation would transform. Facing extinction of a species, we could create sanctuaries across multiple worlds, each perfectly suited to their needs. Running out of clean water, we could access and transport resources from countless pristine sources throughout the galaxy. The energy sector would evolve as we tap into power sources across multiple star systems simultaneously. Solar farms could operate around different types of stars, providing continuous power regardless of local conditions. We could study and harness the energy of various cosmic phenomena directly. Space exploration itself would enter a new era. Instead of sending probes on decades-long journeys, we could step through portals to directly explore distant galaxies. We could establish research stations at the edge of black holes, near the births of stars, or in the hearts of nebulae. The possibilities extend to every aspect of human existence. Artists could draw inspiration from alien sunsets, Musicians could incorporate the actual music of distant spheres. Architects could design structures that span multiple worlds through portal networks. Every field of human endeavor would expand beyond its current limits. This isn't just about making life more convenient. Wormhole technology would fundamentally change what it means to be human. We would no longer be bound by space or time. Our playground would become the entire universe, transforming us from a planetary species into true cosmic citizens. When Albert Einstein published his theory of relativity, he didn't just reshape physics. He put a cosmic speed limit on everything in our universe. Nothing, he declared, could move faster than light. It was a universal speed limit that seemed impossible to break. But what if Einstein wasn't telling us the whole story? For decades, we've accepted that light speed represents the ultimate barrier, roughly 186,000 miles every second. At this velocity, you could circle Earth 7 times in 1 second. Impressive, until you realize the nearest star system, Alpha Centauri, would still take over 4 years to reach. Our dreams of exploring distant galaxies seemed forever locked behind this cosmic wall. But modern scientists aren't content with accepting these limitations. Right now, researchers are exploring radical new theories that could shatter our understanding of what's possible. Let's dive into how they plan to achieve what Einstein said couldn't be done. Enter Miguel Alcubierre, a physicist who proposed something revolutionary in 1994. Instead of trying to break Einstein's speed limit, why not bend the rules? His concept, known as the Alcubierre drive, suggests creating a bubble in the fabric of space itself. Think of space as a sheet. Rather than moving across it, you could bunch up space in front of your ship and expand it behind you, essentially surfing on a wave of space-time. The genius of this approach? Your ship never actually moves faster than light within its bubble. Instead, space itself moves, carrying you along like a surfer riding a cosmic wave. Einstein's laws remain intact, but you could theoretically reach your destination faster than a beam of light taking the normal route through space. In 2024, scientists proposed a groundbreaking solution that could make this concept more practical. Instead of requiring exotic forms of matter or negative energy densities, they discovered a way to create these warp effects using ordinary matter. It's like finding out you can build a rocket ship using regular steel instead of unobtainable metals. This brings us to another fascinating possibility: tachyons. These theoretical particles would be born moving faster than light, just as normal matter is born with mass. While we haven't discovered them yet, their potential existence keeps challenging our understanding of physics. Imagine particles that don't break the cosmic speed limit because they never knew it existed in the first place. But perhaps the most tantalizing approach involves creating shortcuts through the universe itself. Picture space as a piece of paper. Usually, to get from one point to another, you have to travel across the paper. But what if you could fold it, bringing 2 distant points together? These cosmic shortcuts, called wormholes, could theoretically allow us to bypass normal space travel altogether, reaching distant stars in moments instead of millennia. The implications of achieving faster-than-light travel would transform every aspect of human civilization. Imagine boarding a ship in the morning and eating lunch on a planet orbiting Alpha Centauri. Weekend getaways to distant star systems would become as common as flying to another country. Our entire concept of distance and time would need to be rewritten. But it's not just about vacation possibilities. The ability to reach any point in our galaxy quickly would revolutionize resource gathering, colonization, and our understanding of the universe. We could study distant phenomena up close, mine resources from countless worlds, and spread humanity across the stars. Yet significant challenges remain. The energy requirements for these theoretical drives are staggering. Even the most optimistic calculations suggest we'd need more power than our entire civilization currently produces. Creating stable wormholes or manipulating space-time requires technology far beyond our present capabilities. There's also a more profound problem: causality. Moving faster than light doesn't just break Einstein's speed limit. It raises the possibility of arriving somewhere before you left, creating time travel paradoxes that challenge our understanding of cause and effect. Imagine sending a message to yourself in the past, telling yourself not to send the message. These logical loops keep physicists awake at night. However, recent developments have sparked new hope. In early 2025, researchers made breakthrough discoveries linking dark matter to potential faster-than-light travel mechanisms. By applying advanced calculus to previously overlooked aspects of space-time geometry, they've uncovered new possibilities that could make these concepts more achievable. Another promising study from 2024 demonstrated how objects might achieve incredibly high speeds without requiring exotic energy sources. While not technically faster than light, these advancements bring us closer to understanding how we might eventually break through that cosmic speed limit. The scientific community remains divided. Some physicists argue that future discoveries about gravity and space-time might ultimately prove faster than light travel impossible. Others see these recent breakthroughs as the first steps toward a revolution in space travel. Think about what this means for our future. We stand at a crossroads where the impossible seems increasingly possible. Every breakthrough brings us closer to breaking free from the cosmic speed limit that has confined humanity to our small corner of space. The quest for faster-than-light travel represents more than just scientific curiosity. It embodies humanity's eternal desire to push boundaries, to explore, to reach beyond what others claim is impossible. While Einstein's equations still stand, we're discovering they might have more flexibility than anyone imagined. As we continue to unravel the mysteries of physics, one thing becomes clear: the universe is stranger and more wonderful than we ever imagined. Whether through warped space-time, exotic particles, or cosmic shortcuts, we're getting closer to achieving what generations thought impossible. The stars may not be as out of reach as we once believed. Out there in the darkness between the stars, an invisible giant silently moves through our galaxy. It's not a ghost, not an alien ship, but something even more mysterious: a rogue black hole. These cosmic wanderers are nature's perfect predators, invisible until it's too late, detected only by their gravitational influence on space itself. A rogue black hole forms when a star so massive collapses into a point smaller than a pinhead, yet still weighs more than our sun. Freed from its original star system, it drifts through space alone. Scientists believe millions of these cosmic nomads could be roaming our galaxy right now. Finding these wanderers isn't easy. They're completely black, emitting no light whatsoever. It's like trying to spot a ship at sea by looking for the wake it leaves in the water. Instead of watching for light, astronomers look for the way these objects bend and distort the light from stars behind them. This bending of light, called gravitational lensing, works like a massive cosmic magnifying glass. When a rogue black hole passes in front of a distant star, It warps the starlight in a unique way. It's subtle, but with telescopes like Hubble and the upcoming Roman Space Telescope, we can catch these cosmic giants in the act. The implications of finding these wandering black holes are staggering. We're not just discovering objects, we're mapping invisible forces that shape our entire galaxy. Every rogue black hole we find helps us understand how stars live and die, how galaxies evolve, and how gravity itself works. These cosmic drifters could actually help us see further into the universe than ever before. Just as a magnifying glass helps read tiny print, a black hole's gravitational field can act as a natural telescope, allowing us to observe incredibly distant objects that would otherwise be too faint to see. A wandering black hole becomes a cosmic spotlight, illuminating the darkest corners of the universe. As it drifts through space, it temporarily amplifies the light from ancient galaxies, giving us glimpses of the early universe that we could never get any other way. The technology we're developing to hunt these invisible giants pushes the boundaries of what's possible. We're creating instruments so sensitive they can detect the slightest wobble in starlight, computers powerful enough to process vast amounts of astronomical data, and methods to predict where these cosmic wanderers might appear next. The space between stars isn't empty as once thought. It could be filled with these invisible behemoths, each one carrying the mass of multiple suns, silently shaping the galaxy as they travel. The hunt for rogue black holes also teaches us about cosmic safety. While the chances of one coming anywhere near our solar system are incredibly small, mapping their locations and movements helps us better understand our cosmic neighborhood. It's like having a weather forecast, but for space itself. Every detection of these wandering giants reveals more about how galaxies work. These aren't just random objects drifting through space. They're cosmic archaeologists, carrying information about the stars that created them and the parts of the galaxy they've traveled through. The required technology to track these invisible objects showcases human ingenuity at its finest. We're talking about detecting changes in starlight, so subtle they're like spotting a firefly's wing from across the country. Every advance in this field pushes our technological capabilities further, leading to improvements in everything from satellite technology to computer processing. As we plan to send humans deeper into space, understanding where these cosmic giants are and how they move becomes increasingly important. It's like creating a map of underwater currents before sending ships across an ocean. The study of rogue black holes reveals profound truths about our place in the cosmos. These objects prove the universe is dynamic, always changing, full of invisible forces that shape everything around us. Space isn't just a static backdrop, but an active environment full of hidden wonders. Our ability to detect these invisible objects shows humanity's remarkable progress. We're not just looking at visible objects anymore. We're detecting the unseeable, measuring the unmeasurable, and revolutionizing our understanding of the universe in the process. Each discovery adds another piece to the cosmic puzzle. We're learning about stellar death, galactic evolution, and gravity's behavior on the grandest scales. This knowledge is fundamental to understanding our place in the universe and what might be possible in the future. A future exists where we can predict these cosmic wanderers with precision, using their tremendous gravitational fields to our advantage. While we might never harness a black hole's power directly, understanding them could lead to revolutionary advances in how we think about gravity, space, and the fundamental forces of nature. Let's play out this scenario. Scientists have discovered a massive asteroid heading toward Earth, big enough to wipe out civilization as we know it. This isn't the plot of a movie. Right now, astronomers are scanning the skies for exactly these kinds of space rocks, and what they're finding is both terrifying and fascinating. We call them planet killers. These aren't your average space rocks. We're talking about asteroids more than half a mile wide, moving at speeds up to 50,000 miles per hour. Just one of these giants packs enough power to throw so much dust into our atmosphere that sunlight would be blocked worldwide, triggering a chain of events that could end life as we know it. Take asteroid 2022 AP7, for example. This monster crosses Earth's orbit and is big enough to cause global devastation if it ever hit us. It's not alone out there. There could be dozens more hiding in the glare of the sun, invisible to most telescopes until recently. It's like trying to spot a black baseball at midnight, except this baseball could end civilization. But here's where the story gets interesting. We're not sitting ducks anymore. Scientists have developed incredible tools to find these cosmic bullets before they find us. The Dark Energy Camera, one of the most powerful digital cameras ever built, can spot asteroids hiding in places we could never see before, like the area close to the sun's glare. And we're not just getting better at finding them, we're learning how to fight back. NASA recently did something that sounds impossible. They crashed a spacecraft into an asteroid on purpose, and it worked. The DART mission proved we can actually change an asteroid's path through space. Think about that. We can now move entire mountains floating in space. Our tracking abilities are becoming incredible too. New tools like Adam and Thor can predict asteroid paths with amazing accuracy. They can even look through old telescope photos to find asteroids we might have missed. It's like having a time machine that helps us map out the solar system's most dangerous neighbors. But finding and tracking these space rocks is just the beginning. Scientists are working on early warning systems that could spot dangerous asteroids decades before they become a threat. Imagine having 20 or 30 years to prepare for an incoming asteroid. That's not just a safety measure, it's a complete game changer for how we handle cosmic threats. The technology we're developing isn't just about deflecting asteroids either. Some scientists are proposing ways to capture these space rocks and mine them for valuable resources. Picture turning a potential planet killer into a source of precious metals and materials we could use to build spacecraft or orbital stations. This gets even more interesting when you think about the bigger picture. Every asteroid we study is like a time capsule from the early solar system. These rocks have been floating around practically unchanged since the planets formed. By studying them, we're learning about how Earth and other planets came to be. The tools we're creating to track and deflect asteroids are pushing technology forward in amazing ways. We're developing better cameras, more powerful computers, and more precise ways to navigate in space. These advances don't just help us spot asteroids, they improve everything from satellite technology to weather forecasting. Here's something else to think about. For the first time in Earth's history, a species has developed the ability to prevent its own extinction from an asteroid impact. The dinosaurs never saw their doom coming. We can not only see it coming, but we can actually do something about it. This is changing how we think about protecting our planet. Countries that normally compete with each other are working together to track asteroids and plan defense strategies. After all, an asteroid doesn't care about national borders. It's a threat to everyone, and defending against it requires global cooperation. Think about what this means for our future. we're developing the ability to protect our entire planet from a threat that has caused mass extinctions in the past. That's not just amazing. It's a testament to human ingenuity and our ability to solve seemingly impossible problems. The technology we're creating has applications far beyond asteroid defense. The same tools that help us track space rocks could help us navigate spacecraft to distant planets. The engines we design to reach asteroids could power the ships that take us to Mars. Every advance in planetary defense is also an advance in space exploration. And here's the really exciting part. We're just getting started. New telescopes are being built that will be able to spot even more asteroids. Better tracking systems are being developed. More powerful deflection methods are being designed. We're getting better at this every year. This isn't just about survival, though that's important enough. It's about taking control of our destiny as a species. For the first time, we're not just at the mercy of cosmic events. We're developing the power to protect ourselves from one of the universe's deadliest threats. The discovery and tracking of planet-killing asteroids might seem scary at first, but it's actually an incredibly hopeful story. It shows that when faced with a global threat, we can come together, develop amazing new technologies, and find ways to protect ourselves. It's proof that no problem is too big when we put our minds to solving it. Imagine being able to harvest every single drop of energy on Earth, every ray of sunlight, every gust of wind, every ocean wave, every bit of geothermal heat from the planet's core. Now imagine that's just the beginning. This is the story of the Kardashev scale, and it might just be the most important measuring stick for our future as a species. Back in 1964, a Russian scientist named Nikolai Kardashev looked up at the stars and asked a simple question: how do we measure the advancement of a civilization? His answer wasn't about technology or culture or art. It was about energy. The more energy a civilization could harness and control, the more advanced it would be. Right now, we're not even at the first level of his scale. We're at type 0.73, which means we're still crawling toward becoming a true planetary civilization. We're like teenagers who haven't quite figured out how to use all our resources responsibly. Within the next century or two, we could reach type 1 status, becoming masters of our entire planet's energy. Think about what that would mean. No more fighting over oil. No more worrying about running out of electricity. No more choosing between economic growth and environmental protection. We'd have access to all the power our planet could provide, and we'd know how to use it without destroying our environment. But that's just level 1. Level 2 is where things get really wild. Imagine building structures around our sun to capture every bit of energy it produces. We're talking about engineering on a scale that makes our largest buildings look like toy blocks. A civilization at this level could power millions of worlds, control the weather on planets, and maybe even move entire solar systems. And level 3? That's when you become rulers of an entire galaxy. Picture having the power to use every star, every black hole, every source of energy in billions of solar systems. Want to reshape a star system? No problem. Need to move a planet? Just another Tuesday for a Type 3 civilization. Some scientists have even proposed level 4 and 5 civilizations that could control multiple galaxies or even create new universes. At this point, we're talking about beings so advanced they'd seem like gods to us today. We can actually look for these civilizations out there in space. A Type 2 or 3 civilization would use so much energy that we might be able to spot them from Earth. Those weird signals astronomers sometimes pick up, some of them could be the energy signatures of super-advanced aliens going about their daily business. This isn't just about classification either. The Kardashev scale is like a roadmap for our future. Want to become a spacefaring civilization? You'll need Type 1 energy manipulation at least. Want to colonize other star systems? Better figure out how to reach Type 2. Want to explore the galaxy? Type 3 is your goal. Each step up the scale would fundamentally change what it means to be human. Reaching Type 1 requires global cooperation on a scale we've never seen before. We'd need to put aside our differences and work together to master our planet's energy. It's not just about technology, it's about growing up as a species. Type 2 would transform us from a planetary species into a stellar one. We'd need to think in terms of centuries rather than years, working on projects that might take generations to complete. The engineering challenges would push us to develop technologies we can barely imagine today. And Type 3, we'd become true galactic citizens, able to reshape the cosmos itself. Our descendants might look back at our current civilization the way we look back at our cave-dwelling ancestors. The gap in capabilities would be that vast. But maybe the most profound aspect of the Kardashev scale is what it tells us about our potential. Every time you look up at the night sky, you're seeing uncounted stars and galaxies full of energy just waiting to be harnessed. All that power, all that potential just sitting there, and we're taking our first baby steps toward claiming it. The scale also gives us perspective on our current challenges. Worried about running out of resources? A Type 2 civilization wouldn't even understand the concept of energy scarcity. Concerned about climate change? A Type 3 civilization could terraform planets for fun. Everything that seems impossible to us now becomes trivial as you climb the scale. Think about what this means for our future. Every advance in solar power, every improvement in fusion research, every breakthrough in energy storage is pushing us closer to Type 1 status. We're not just developing technology, we're climbing an energy ladder that stretches to the stars. And here's the most exciting part. We're alive at the beginning of this journey. Our generation could be the one that helps humanity take its first real steps toward becoming a Type 1 civilization. The Kardashev scale isn't just a way of measuring civilizations, it's a vision of what we could become. It's a reminder that our current energy challenges are just temporary obstacles on a much longer journey. And it's a promise that the future could be more amazing than we ever imagined. Life on Earth has its limits. We know this every time we hear about overcrowded cities, depleted resources, or environmental concerns. But what if we could expand beyond these boundaries? Space colonies represent more than just an escape plan. They offer us a chance to reimagine human civilization itself. Picture waking up in an orbital habitat with Earth floating outside your window. Your morning commute takes you to a manufacturing facility that produces advanced electronics in zero gravity. After work, you might visit friends living in the lunar colony or take your kids to see the red deserts of Mars. This isn't fantasy. This is the future that space colonies could make possible. The possibilities for these settlements extend far beyond single locations. The Moon offers us a nearby base rich in helium-3 and water ice, perfect for fuel production and sustaining life. Mars presents an entire planet ready for transformation, with resources waiting to be tapped. Asteroids float through space like cosmic treasure chests, packed with valuable minerals that could drive an entire space economy. But perhaps the most fascinating option involves massive orbital habitats known as O'Neill cylinders. Picture enormous rotating structures creating artificial gravity through centrifugal force, with entire ecosystems built inside. These massive space cities could house millions, complete with parks, lakes, and open skies that rival Earth's own beauty. These colonies would do more than just give us new places to live. They could solve many of Earth's most pressing problems. Imagine vast solar power stations in space, collecting the sun's energy 24 hours a day and beaming it back to Earth as clean, unlimited power. No more energy crises, no more burning fossil fuels, just abundant, renewable energy for everyone. The environmental benefits would be tremendous. By moving heavy industry into space, we could eliminate much of the pollution that plagues our planet. Manufacturing in zero gravity often produces better results anyway, especially for electronics and pharmaceuticals. Earth could begin to heal while we continue to advance technologically. Resource scarcity, that becomes a thing of the past when you have access to entire asteroids made of precious metals. A single space rock could contain more platinum than has ever been mined in human history. With space colonies, we gain access to a virtually unlimited supply of raw materials. But the true revolution comes in how these colonies could reshape human society. Imagine communities designed from the ground up with sustainability in mind. Every drop of water recycled, every bit of material reused. The technologies we develop for space habitats could revolutionize how we handle resources on Earth. These settlements would also protect humanity from extinction-level events. An asteroid headed for Earth? We'd have populations safely spread across multiple locations. A global pandemic? Space colonies would provide naturally quarantined populations. We would no longer have all our eggs in one planetary basket. The medical breakthroughs alone could transform life for everyone. Research in microgravity leads to advances in pharmaceuticals and regenerative medicine that aren't possible on Earth. Imagine new treatments for cancer, revolutionary approaches to organ growth, or breakthrough drugs that could only be developed in space. Education would evolve as well. Children growing up in space colonies would learn entirely new fields of science and engineering. They would develop skills we can barely imagine today, preparing for jobs that don't yet exist. Every generation would push the boundaries of human knowledge further into the cosmos. Consider the cultural impact. Space colonies would bring together people from all nations, fostering international cooperation and understanding. New forms of art would emerge, inspired by otherworldly environments. Music would evolve to incorporate the unique acoustics of space habitats. Architecture would explore entirely new possibilities under different gravitational conditions. Sports would transform in exciting ways. Imagine Olympic events in varying gravity levels, or entirely new games developed for space environments. Entertainment would expand to include experiences unique to space living, creating new forms of recreation we can only dream about now. Agriculture would advance in revolutionary ways. Vertical farming in controlled environments would provide fresh food year-round, regardless of external conditions. These techniques could then be applied back on Earth, helping to feed growing populations more efficiently. The economy would evolve as well. New industries would emerge around space resources and manufacturing. Jobs would be created in fields that don't even exist today. The wealth generated from space resources could help eliminate poverty on Earth, creating a more equitable society for everyone. Transportation networks would connect these various colonies, creating a thriving interplanetary civilization. Regular shuttle services would move between Earth, Moon, and Mars. Asteroid mining operations would establish supply routes throughout the solar system. Humanity would truly become a spacefaring species. Research opportunities would be endless. Scientists could study everything from the effects of different gravity levels on human biology to the behavior of materials in space. Every colony would serve as a laboratory for advancing human knowledge and capabilities. Even tourism would be transformed. Imagine hotels in orbit, lunar resorts, or guided tours of Martian canyons. People could experience environments and views that were once limited to astronauts and astronomy photographs. The psychological benefits might surprise us too. Looking back at Earth from space often gives astronauts a profound shift in perspective known as the overview effect. Imagine an entire generation growing up with this broader view of our place in the cosmos. These colonies represent more than just new places to live. They represent humanity's next great adventure. They offer us chances to reinvent ourselves, to build better societies, to solve problems that seem insurmountable on Earth alone. With space colonies, we're not just reaching for the stars. We're creating new homes among them. Each settlement would serve as a testing ground for new ideas and technologies. What works best could be shared and implemented elsewhere, creating a constant cycle of innovation and improvement. We would learn and adapt faster than ever before in human history. The red dust stretches endlessly toward the horizon, broken only by the gleaming domes of humanity's first interplanetary city. This isn't science fiction anymore. Mars colonization represents our first real step toward becoming a multi-planetary civilization, and it could change life on Earth in ways we never imagined. But what makes Mars special? For starters, it's like a cousin to Earth. A day on Mars lasts just 24 hours and 37 minutes, meaning your body clock would barely notice the difference. Its gravity, while lighter than Earth's, is strong enough to keep your bones and muscles healthy. Most importantly, Mars has everything we need to sustain life, if we know where to look. Water ice lies hidden at the poles and just beneath the surface, ready to be extracted and purified. The atmosphere, though thin, contains carbon dioxide we can transform into oxygen and rocket fuel. The soil holds valuable minerals that could support both industry and agriculture. Mars isn't just another rock in space. It's a potential second home for humanity. The most promising locations for our first settlements have already been identified. The poles offer easy access to water ice, crucial for drinking, growing food, and producing fuel. Ancient lava tubes and natural caves could shelter colonists from radiation and extreme temperatures, creating ready-made habitats that would take minimal effort to seal and pressurize. The Hellas Planitia, a massive impact basin, has higher atmospheric pressure than anywhere else on Mars, making it slightly easier to create livable spaces. But establishing a Mars colony would do more than just give us a new place to live. Think of it as humanity's ultimate insurance policy. Right now, all our eggs are in one basket called Earth. A single asteroid, global pandemic, or nuclear war could wipe out everything we've built. With a thriving Mars colony, humanity would have a backup, ensuring our species survives even if disaster strikes our home planet. The technologies we develop for Mars would revolutionize life on Earth. Imagine creating systems that recycle nearly 100% of water and air, turning waste into valuable resources. These same technologies could help solve water scarcity and pollution problems back home. The energy systems we design for Mars colonies could lead to breakthroughs in renewable energy on Earth. Agriculture would evolve in amazing ways. Growing food on Mars means developing advanced hydroponics and vertical farming techniques that could transform how we feed people on Earth. Imagine farming systems that produce maximum yields with minimal resources, all while recycling every drop of water and nutrient. These techniques could revolutionize agriculture in desert regions or urban areas. The economic opportunities are staggering. Mars has vast deposits of rare metals that could supply industries back on Earth. Water ice could be split into hydrogen and oxygen, providing fuel for spacecraft throughout the solar system. Over time, Mars could become a manufacturing hub, using its lower gravity to produce materials and products that would be difficult or impossible to make on Earth. Scientific discoveries would accelerate at an unprecedented pace. Studying Mars up close could answer fundamental questions about the origins of life in our solar system. We might find evidence of ancient microbial life, helping us understand how life begins and evolves. The geological history of Mars could provide crucial insights into the Earth's own past and future. Perhaps most fascinating is how a Mars colony would develop its own unique culture. Imagine a society built from scratch, free to experiment with new forms of governance and social organization. The first generation of Martian-born humans would see the universe differently than anyone before them. They would develop their own customs, their own slang, maybe even their own dialect of existing languages. The entertainment industry would evolve in fascinating ways. Sports in Mars's lower gravity would look completely different. New forms of art would emerge, inspired by the stark Martian landscape and the experience of living on another world. Reality shows would document the daily lives of Mars colonists, while virtual reality feeds would let people on Earth experience Mars firsthand. Education would transform as well. Schools would need to prepare students for life on two worlds. Children would learn about atmospheric pressure as naturally as they learn about rain, and understanding radiation protection would be as basic as knowing how to use an umbrella. Every subject, from physics to physical education, would adapt to incorporate the Martian environment. Transportation between Earth and Mars would become routine, creating new industries and job opportunities. Space tourism would expand to include Mars excursions. Hotels would offer rooms with views of Olympus Mons, the largest volcano in the solar system. Adventure tourism would take people on guided expeditions through Valles Marineris, a canyon system that makes the Grand Canyon look tiny. Healthcare would advance rapidly as we learn to treat medical conditions in Martian gravity. New surgical techniques would be developed, new medications tested, new ways of maintaining human health in an alien environment discovered. These breakthroughs would benefit everyone, whether they live on Mars or Earth. Construction techniques would evolve as we learn to build with Martian materials. 3D printing with local resources would become standard practice. We might develop new types of concrete using Martian soil, or discover better ways to create radiation shielding. These technologies could revolutionize construction on Earth, especially in remote or hostile environments. Communication systems would need to overcome the time delay between Earth and Mars, leading to innovations in data transmission and storage. New forms of social media would emerge to help people maintain connections across planetary distances. These advances could improve internet infrastructure and digital communication everywhere. A Mars colony represents more than just a scientific achievement. It's humanity's first step into a larger world, opening doors we can barely imagine today. Every challenge we overcome, every system we develop, every discovery we make brings us closer to becoming a truly spacefaring civilization. Forget everything you think you know about the moon. That lifeless rock in our night sky. It's about to become humanity's next home, and it could change everything about how we live, work, and explore space. A moon base isn't just another space station. It's our first real home beyond Earth, and it's closer to reality than you might think. Right now, both NASA and China are racing to build permanent settlements near the moon's poles. These won't be simple camping trips. We're talking about actual bases where people will live and work for months or even years at a time. Think of it like building the first city in a new world, except this world is right in our cosmic backyard. But why the poles? Because that's where we find one of the moon's most precious resources, water ice. Hidden in permanently shadowed craters, this ice is like striking gold in space. We can drink it, break it down into oxygen to breathe, and even turn it into rocket fuel. Instead of hauling every drop of water from Earth at enormous cost, we can use what's already there. The possibilities of a moon base go way beyond just having a cool place to plant flags. Imagine telescopes built on the far side of the moon, completely shielded from Earth's radio chatter and light pollution. These instruments could peer deeper into space than ever before, possibly helping us spot habitable planets around other stars or unlock the mysteries of black holes. Then there's helium-3, an element rare on Earth but plentiful in lunar soil. This isn't just any old gas. Scientists believe it could power nuclear fusion reactors, potentially giving us a clean, safe, and nearly limitless energy source. A single space shuttle load of helium-3 from the moon could power the entire United States for a year. The moon could also become our cosmic gas station. Its lower gravity means it takes way less fuel to launch spacecraft from the lunar surface than from Earth. By producing fuel from lunar ice, we could turn the moon into a refueling depot for missions to Mars and beyond. It's like building a pit stop on humanity's highway to the stars. Think about space tourism too. Imagine hotels with views of Earth hanging in the black sky, offering experiences you literally can't get anywhere else on Earth. Want to play sports in 1/6 gravity? How about driving a rover across a lunar mare? These aren't just tourism gimmicks. They're the beginning of a whole new branch of human culture and commerce. Scientists would have a field day with a permanent moon base. Every rock they study could tell us more about how Earth and the moon formed. Every experiment in lunar gravity could teach us more about how to live and work in space. Even the dust would be interesting. Moon dust is incredibly fine and electrically charged, making it a unique challenge for engineers to deal with. Solving these problems could lead to new technologies we can use back on Earth. A moon base would also serve as our practice run for Mars. Think about it. Before we send people on a month-long journey to the Red Planet, wouldn't it be smart to test our life support systems, growing techniques, and construction methods somewhere closer to home? The moon is just a 3-day trip away. If something goes wrong, help isn't months away like it would be on Mars. The economic potential is staggering. Beyond mining helium-3 and water ice, The Moon has rare Earth elements that are crucial for electronics and renewable energy technology. Companies are already making plans to extract these resources. This could create entirely new industries and job markets. Your kids might grow up dreaming of becoming lunar miners or moon base engineers. Building permanent structures on the Moon would push technology to new limits. We'd need to develop new materials that can withstand extreme temperature swings, new ways to shield against radiation, new methods for 3D printing buildings using lunar soil. These advances wouldn't just stay on the Moon. They could help us build better, more sustainable structures on Earth. The base would need to recycle nearly everything to survive. Water, air, even human waste would be processed and reused. Developing these closed-loop systems could revolutionize how we handle resources on Earth. Imagine cities that recycle 100% of their water, or buildings that never waste a breath of air. Energy systems would need to be incredibly efficient and reliable. Solar panels would need to work during the 2-week-long lunar nights. Power storage systems would need to handle temperature extremes. Solving these challenges could lead to breakthroughs in renewable energy technology for Earth. Food production would push the boundaries of agriculture. Growing food in enclosed lunar greenhouses using hydroponics and artificial lighting could teach us valuable lessons about farming in harsh environments on Earth. These techniques could help feed people in desert regions or urban areas where traditional farming isn't possible. But perhaps the most profound impact of a moon base would be on our perspective as a species. Every astronaut who sees Earth from space talks about how it changes their outlook on life. Imagine entire communities living on the Moon, looking back at our blue marble floating in space. How would that change our understanding of what it means to be human? A moon base isn't just about planting flags or proving we can do it. It's about taking the first real steps toward becoming a spacefaring civilization. It's about learning to live sustainably in the harshest environment imaginable. It's about pushing the boundaries of human knowledge and capability. Most importantly, it's about securing humanity's future among the stars. Now, an easy life-changing discovery in space would be the discovery of alien life. But the reality of finding it and what that discovery means for humanity is far more complex than science fiction has led us to believe. The truth is, alien life might not arrive in sleek metallic ships or make first contact through radio signals. Instead, it could be found in the chemical signatures of a distant planet's atmosphere, or in microscopic fossils buried beneath the icy surface of a moon in our own solar system. Every day, scientists scan the cosmos for signs of life, but they're not just looking for advanced civilizations. They're searching for the subtle fingerprints that life, in any form, leaves behind. These biosignatures could be as simple as an unusual mix of gases in an exoplanet's atmosphere, or organic compounds that shouldn't exist naturally without the presence of living organisms. The most profound aspect of discovering alien life isn't just about finding it. It's about what that discovery would mean for every human being on Earth. From the moment we confirm the existence of life beyond our planet, everything changes. Our textbooks, our religions, our understanding of our place in the universe. All of it would need to be reconsidered in light of the fact that we are not alone. Consider the possibility of microbial life, the most likely form we might discover first. These tiny organisms could be thriving in the subsurface oceans of Europa or Enceladus. or perhaps clinging to existence in the ancient riverbeds of Mars. Such a discovery would revolutionize our understanding of how life begins and evolves. If life emerged independently twice in our solar system alone, the implications would be staggering. It would suggest that life isn't a cosmic accident, but a common occurrence throughout the universe. But finding this evidence requires more than just looking through telescopes. Scientists are developing increasingly sophisticated tools, including artificial intelligence systems that can analyze vast amounts of data for patterns that might indicate biological activity. These same technologies are pushing the boundaries of what's possible here on Earth, leading to breakthroughs in medicine, computing, and our understanding of life itself. The James Webb Space Telescope peers into the atmospheres of distant worlds, looking for chemical signatures that could only be produced by living organisms. Mars rovers analyze soil samples for traces of ancient microbes. Radio telescopes scan the stars for signals that might indicate intelligent life. What makes this search truly revolutionary is how it forces us to question our most basic assumptions about life. We've always defined life based on what we know from Earth: carbon-based, requiring water, thriving in certain temperature ranges. But alien life might break all these rules. It might use different solvents than water, different building blocks than carbon, or exist in conditions we consider impossible for life. The discovery of even the simplest alien organism would force us to expand our definition of what life can be. It would open up entirely new fields of study in biology, chemistry, and physics. Scientists would need to understand how this life emerged, how it functions, and what this means for the possibility of life elsewhere in the universe. The impact wouldn't just be scientific. The confirmation of alien life would trigger a philosophical and cultural revolution. Every human society would need to grapple with what this means for their worldview. Religious institutions would face questions about how this discovery fits into their understanding of creation. Governments would need to develop new protocols for studying and potentially interacting with alien life forms. The technology we're developing in this search is already changing lives on Earth. The same tools we use to look for biosignatures on other worlds are being adapted to detect diseases, analyze environmental changes, and push the boundaries of artificial intelligence. The machines we're building to explore hostile alien environments are inspiring new robotics technologies that could be used in disaster response, deep-sea exploration, and other challenging environments on Earth. But perhaps the most profound change would be in how we see ourselves. Right now, humanity stands at a unique point in its history. We are technologically advanced enough to search for alien life, but we haven't found it yet. This puts us in a state of possibility where we can still wonder about our place in the cosmos. The moment we confirm the existence of alien life, that changes forever. If we find simple life forms, it would suggest that life is common in the universe, but complex life might be rare. This would make our existence even more precious and perhaps drive us to be better stewards of our planet and our species. If we find evidence of intelligent life, it would raise new questions about our future and our potential place in a larger cosmic community. The tools we're developing for this search are becoming increasingly sophisticated. Pyrolysis gas chromatography mass spectrometry allows us to analyze the chemical composition of samples with incredible precision. Artificial intelligence systems can process vast amounts of data, looking for patterns that might indicate biological activity. Each new technology brings us closer to potentially making the most important discovery in human history. The search for alien life represents more than just scientific curiosity. It's about understanding our origins, our future, and our place in the universe. It's about pushing the boundaries of human knowledge and technology. And most importantly, it's about being ready for a discovery that would change everything we think we know about life itself. As we continue to explore the cosmos, each new discovery brings us closer to potentially answering that fundamental question: are we alone? The answer, whether yes or no, will change life as we know it, and that change will ripple through every aspect of human society, from science and technology to philosophy and religion, forever altering our understanding of what it means to be alive in this vast, mysterious universe. In the depths of space, where vast clouds of gas and stardust paint celestial masterpieces across the cosmos, scientists have begun to notice something extraordinary. These nebulae, traditionally viewed as nothing more than cosmic nurseries for new stars, might hold a secret that would shake the very foundation of what we consider to be alive. The living nebula theory isn't about finding little green men or advanced alien civilizations. It's about something far more profound. What if life, as we understand it, isn't limited to the carbon-based creatures crawling on planetary surfaces? What if consciousness, metabolism, and evolution could exist in the swirling clouds of interstellar space itself? Right now, somewhere in our galaxy, there could be a nebula that defies everything we know about life. Unlike the stars and planets we're familiar with, this cosmic cloud might show signs of self-organization, adapting to its environment in ways that mirror biological systems on Earth. But instead of using DNA and cellular structures, it could be orchestrating its existence through plasma reactions and electromagnetic fields. Think about what we consider alive. Every definition we have is based on what we've observed on our tiny blue planet. We look for things that can reproduce, metabolize energy, respond to their environment. But a living nebula would force us to throw out this earthbound rulebook. Instead of consuming organic matter for energy, it might feed directly on starlight or harness the power of nuclear fusion. Rather than passing on genetic information through DNA, it could transmit patterns through waves of plasma or quantum states we barely understand. The most fascinating aspect isn't just that such an entity could exist. It's what its existence would mean for our search for life in the universe. If a cosmic cloud can be alive, then life isn't just more diverse than we imagined. It's more diverse than we could have imagined. Scientists studying these possibilities aren't just looking at nebulae through traditional telescopes. They're developing new ways to detect signs of large-scale organization and pattern formation that shouldn't exist without some form of internal regulation. They're searching for evidence of nebulae that maintain their structure despite the chaos of space, that respond to external stimuli, that show signs of growth or adaptation over time. But finding such evidence would only be the beginning. The real challenge would be understanding how it works. How does a cloud of gas and dust achieve consciousness? How does it think, if it thinks at all? Our brains use neurons and electrical signals, but a living nebula might process information through fluctuations in magnetic fields or quantum entanglement on a cosmic scale. The implications of such a discovery would reach far beyond astronomy and biology. Engineers could study how it processes energy to develop new power systems. Computer scientists might find inspiration for new forms of artificial intelligence based on its distributed consciousness. Philosophers would need to reconsider what it means to be alive, to think, to exist. Consider the possibility that such a being could be intelligent, even conscious. Its thoughts might take years to form, playing out across light years of space. Its memories could be encoded in the very structure of its constituent matter. It might have been aware of us all along, watching our civilization develop, operating on a timescale so vast that our entire species' existence is nothing more than a brief moment in its cosmic contemplation. The technology required to study such an entity would push the boundaries of human innovation. We'd need new kinds of sensors to detect its subtle electromagnetic patterns, new computational models to understand its behavior, new theories to explain its existence. Each advance in these areas would have practical applications on Earth, from improving our understanding of complex systems to developing new energy technologies. The discovery of a living nebula would also force us to confront some uncomfortable questions. If life can exist in such an alien form, how many other forms of life have we missed? What if some of the cosmic phenomena we've been studying for centuries are actually living beings? The stars, the galaxies, the cosmic web itself. Could they all be part of some vast, living system that we're only now beginning to recognize? This revelation would change our approach to space exploration and research. We'd need new ethical guidelines for studying and interacting with these cosmic life forms. We'd have to consider the possibility that our activities in space could affect these beings, just as our actions on Earth affect its ecosystems. Perhaps the most profound impact would be on our understanding of our own existence. We've always thought of life as something that happens on planets, bound by gravity and atmospheric pressure. But if life can exist in the vacuum of space, in forms so alien we barely recognize them as alive, then the possibilities for life in the universe become virtually limitless. The search for a living nebula represents more than just scientific curiosity. It's about expanding our understanding of what's possible, about breaking free from the limitations of our Earth-based perspective. It's about recognizing that life, consciousness, and intelligence might manifest in ways we never dreamed possible. As we continue to explore the cosmos, we must remain open to these possibilities. The next time you look up at the night sky, remember that those distant clouds of gas and dust might not just be beautiful cosmic formations. They could be the thoughts of a being so vast and alien that we're only now learning to recognize its existence.